and endpoint detection and response. Also on the Cyber DIA Technology Advisory Board here at Temple. We're excited to continue to work with Temple. Was here today in class listening to students present, and also get to meet some of these cyber students here at Temple. So very exciting, and excited to be here on the panel today.
Professional Science Masters brings in, it's very much aligned with industry. We not only bring the industry materials, as you can see by having Scott today in the classroom, we also bring our cyber professionals to have talks directly with our students. And we use their tools and some other insights from our advisory board members to help shape the program. So we very much like to be industry aligned, and that's what's going to help eventually grow our students, build up their resumes in order to get those opportunities in job employment. An example is today. So Scott is still looking for, is looking for talent, and he started by coming to Temple and meeting the people directly. So we had our panelists briefly introduce each other. And I am very excited because today we're going to be talking about critical infrastructures, the threats and concerns for cyber in different perspectives with critical infrastructures. So with that, I want to invite the panel not only to share with each other and go in dialogue, but maybe let's even start with an incident or an event that happened that's of interest, because people have no idea how close we are sometimes to some kind of disaster that's cyber related.
Being in the managed security services business, we do see lots of things. I guess you could considering where we are with the pandemic and so forth, healthcare obviously being part of the critical infrastructure as well with hospitals and stuff. We actually had a hospital partner get hacked. We weren't covering that area of the business, but they actually were attacked by ransomware and were basically shut down. It was funny. We were monitoring the actual end hospitals, but their end data center, which strangely enough, they didn't have us monitoring, was what got hacked, and it shut down all the hospitals because the ransomware, all the systems were accessing that data center. So they ended up having to pay to get it resolved, and it affected them right in the middle of the pandemic. They're trying to service people that are sick and ill, and they're having issues just keeping their systems running inside the hospital. And I remember a very frantic situation, or on the phone with them, working directly with them, trying to see if we could help and stop it. But unfortunately, we didn't have a purview into the area that was attacked. And it didn't spread because it didn't have to, because it was in the core of the database systems that were encrypted. But they ended up paying the ransom to get out of it. They tried to hire a firm to come in and help, and that didn't work. It took them, I think, about 6 or 7 days.
Wow. And just to give an idea of what are critical infrastructures, I mean, we're talking finance, hospital, the gas thing.
I mean, the water sector is another example of those critical infrastructures. The water sector, one of the things that we have to be concerned with, are we being attacked by malicious activities, or is it a natural phenomenon? And the systems engineers that operate these facilities have to be mindful of the type of attack that can occur on the system. And recently had the Hurricane Ida come through and put down some of these control systems that operate the plants to supply distribution of water. Incidences like having sewage mixed with potable water is not a good thing, and so we have to have systems in place to be monitoring the activity on the industrial control system. But can those activities be malicious, or can they be a natural phenomenon? And oftentimes we can tell the difference between those two, especially when you can see the damage that occurs from a physical nature. But what if those aren't so obvious and they occur with malicious events where there's activity to control the system and operate it in a way that it wasn't designed. And this is not just the water sector. This could occur in the gas. This can occur in the power sector. So cyber is a serious concern in our country, and we have to have professionals that know how to detect and prevent and thwart any type of activity. And so we need to educate the folks to understand how systems are working from an ICS perspective as well as an IT perspective. There's lots of tools out there. One of those tools being Logarithm, and not trying to endorse the company, but those tools set up dashboard systems that people can set up features to watch over the systems. And it requires professionals to understand how those systems work and what they need to do to report incidences that occur. And it also helps the folks that design the machinery systems that go into those industrial control systems to improve designs. Because oftentimes you might find that maybe something didn't quite work right or something needs to be improved. So there needs to be lines of communication between the IT, the industrial control systems, and the engineers that are designing the systems. And as educators and people that work in the industry, it's important that that there's training and there's opportunity for students to understand how these systems work. From a legal perspective, it's always good for the legal professional folks to understand how these systems work, not to the extent of an engineer, but to be able to communicate and be able to understand what the system and the people are up against when they are operating these systems. So we're getting into areas that are critical, and the United States and the Department of Defense, Department of Homeland Security, all these government activities need people to understand these systems so we can protect the homeland.
Can we break it down just a little bit, the difference between like OT and IT? You were saying some really key acronyms, but I don't know that people understand that one thing is our email servers or our database servers, but then there are other components that we bring in when it comes to like the water, the electric. Can you share some of that?
Yeah, the operational side of the house, the folks that build the system, put it all together, those folks have to understand the interplay between that and the industrial Internet of Things. These are connected devices that either are controlled to the machinery systems, and you have the IT people monitoring that. So in a sense, you've had to combine the OT and the IT professionals to understand the system. Years ago, it was more separated because you had the IT folks focusing on the control, the computer, and the system architecture, where the machinery systems that go into the system were designed by another set of people. And sometimes those were separate areas, and we needed to combine them in a sense where we can talk across the lines. How do we design a system that we can remotely monitor and secure it at the same time? And so we've combined these kinds of fields where the industrial control system person knows a little bit more about the IT requirements, and the IT professional knows a little bit more about the machinery systems that go into the control system. And having that flow of communication between those two, you're going to get a much better operation of the system as a whole. Hopefully that kind of gives you a sense of the where things are at.
Kind of spinning off of that a little bit with what Sherman was saying. So that idea of ideally for perfect security, if whatever's touching the infrastructure, in the case of water is a great example, whatever's actually opening sluice valves and dams, or whatever is actually that incident earlier in the year in Florida, whatever is actually adding lye to water in order to try to affect the alkalinity of the water, all that equipment, technically to be safe, you want that nowhere near the internet. You want that air gap so nothing's getting out to the outside world. But that's so horribly inconvenient. The whole point of all of this stuff, they could do things the old school way and everything manually, but all of this wonderful industrial Internet of Things kind of technology that lets the machines do things for you, all these companies want to take advantage of them. And to truly be as useful as possible, you can imagine all the smart devices that we all use, they're great, but when they lose the internet, why bother? Well, when trying to keep that air gap, that removal from the internet of the operational side of things, remove some utility. So a lot of companies kind of don't. And in the case of that Florida attack, that was if I remember reading the story properly, that was TeamViewer, just a remote application that's free and accessible, and it might not have even been the commercial version they were paying for, where there was one password and one username the entire company used, and somebody just connected. It went right to that operational side of the house. They adjusted those levels of lie. Somebody noticed, but it could have been a horribly bad thing. And it opens that idea of, was it a nation state actor? Was it just I mean, quite frankly, likely an inside job, a former employee or an angry employee, because that's sort of the simplest solution. But just in that interest of, it's much more easy doing this from home and not having to go into work. That's why we take advantage of the technologies. Well, that ease of use and connecting, again, IT and OT, so the functional side and the business side meet, and they meet the internet, and well, clearly bad things happen.
Yeah, I mean, you mentioned some key things there. Disgruntled employees, insider threats. Insider threats, for those that don't really understand that too much, insider threat is probably one of the highest ranked concerns any company will have, because the individual that wants to commit a crime against their own company knows something about the structure of that company and has possibly access to the system. So as an IT professional, you have to be able to monitor the activities of some of the own workforce. And you might not know when and where things could happen, because this is a random thing in most cases. So monitoring activity of the client server is very important. Monitoring outside activity is very important. Industrial Internet of Things does connect us to the internet more so than in most cases that we like to. So there needs to be firewalls and safeguards. Edge computing devices certainly connect us closer to the internet. And as technology improves, we also have to improve the way we monitor the systems. And whether we're using things like machine learning to understand the behavior of the client or the device, those machine learning and mathematical approaches that go behind the nature of that is used to help aid the monitoring part of the business. And those areas of machine learning and artificial intelligence opens up a wide area for intelligence to the community of preventing any kind of malicious activity or attack. There's also things for this community that I want to make aware of, are things like static analysis and dynamic analysis, where you could have code that's written, and the code might do things that open up the door for simply backdoors. And the code needs to be scrutinized, and we use tool sets and things like that to understand when somebody writes code before it goes to production. Does that code have vulnerabilities in it? And if it does, we have to look at those vulnerabilities, because you don't want somebody to hijack a system because there was a backdoor to the software or the code that was written to allow somebody to exploit the company. And the same like with dynamic analysis tool sets, where we have hyperlinks on web servers, web clients, things that people will use so that they don't have to download it on their own computer. They can do a web hosted system. And if that system that's being hosted on the web has issues with the code that was written for it, then people can exploit the system. So there needs to be dynamic analysis done on the code. And so as educators, we have to do our due diligence to create an environment that people know the tools and the schemes that could be used to detect the code as well as the physical infrastructure.
What do you think of the latest pipeline attack? Where do you think they could be doing any better? Or what laws are dictating what security should be in place?
Unfortunately, there's a wonderful picture everyone has of, well, the government takes care of us, the government has control of this. TV makes it great. The folks in the dark suits come strolling in and secure everything. Reality can drift a bit from that. There's no direct government oversight that requires levels of cybersecurity in most elements of critical infrastructure, and just the way it ends up working. So things have improved in terms of something being in place, but it's not as directed as people, well, like to think, to sleep better at night and enjoy that glass of water. The way it works is there is a coordinating effort on the part of the Department of Homeland Security and CISA, and they create what are known as sector coordinating councils, in which elements of the industry, so elements of the water industry, different companies and professional organizations all work together, but it's voluntary to join. And it's a great conduit of information. And there's a government coordinating council for each sector that marries up to it. And those include agencies, in the case of that water example, the EPA being one of the lead ones, but a number of different government, state, local, and tribal agencies that work in that same field. And they all work together to communicate. But communication is really where it stops. I actually had the chance, because we've been talking water, I had the chance to peek at the 2021 sector and review report that the sector, the Council for the Water Sector prepares. And almost 60% of the respondents to a survey at the end of the year in 2020 that actually provided information, almost 60% of these water utilities actually included cybersecurity in their review of their security infrastructure, meaning more than 40% didn't even include it in their threat review. Nobody forces them to. The nature of our country is that we don't have government getting into private industry. And what we don't like to admit, but it's the truth, all of these utilities, are the majority in most of the sectors, are private entities. So they do the best they can, but they answer to the bottom line. They have to answer to operating budgets. I think about a quarter of them spend less than 1% of their budget on cybersecurity, clearly explaining why, well, as circling back around to my other example, why there can be a water provider in Florida using old operating systems and old TeamViewer, and that being connected to operational systems. There's not a stick in place, understandably, with the way that we like our government to work, but there's not a stick in place to force these entities to actually maintain any level of cybersecurity.
Yeah, I mean, cybersecurity is expensive. It's a cost factor for the company or business to operate, and it takes away from the bottom line. And yes, there needs to be better oversight, better government control for private sector, because the private sector affects people the same way as federally sponsored programs that mandate these kind of controls. And when you have systems that aren't quite up to the necessary cybersecurity requirements, it can create havoc. And you see that a lot in the news. And the only way it's going to get better is if there is some controls from the government side of the house to implement these to the private sector. Of course, it's going to require funding as part, and I wouldn't be surprised if our infrastructure upgrades include things like that. I haven't read the bills. I don't know specifically what's in those infrastructure updates, but certainly that needs to be thought of. And our political figures and lobbyists that may not know enough about cybersecurity and its concerns need to, and they need to be educated. And as educators and providing workforce development to industry, I think helping both the lawmakers, the business folks that run these companies, a good, I mean, we would be doing a good service to those industries to provide them with workforce development and understanding the implications of why we have to have cybersecurity in this world today. And if we don't, then it's going to be troubling. And so I think looking at the numbers that Doug provided there, yes, we have to be very concerned about infrastructures, particularly private industry companies to implement the security features that they need. And if we don't do that, we're going down a really bad path. So we need to open up the doors for these companies to have the right funding necessary in place and the mandate in place for them to have cybersecurity in place. There's companies like Comcast has features to their service that provide security at the point of the network to the businesses. Those are good, but they're not entirely a peace of mind, because you can still have systems break down from within the system. It has to be evaluated. The architecture of the system that the company is using needs to be evaluated. There needs to be some information assurances performed on the hardware. For example, we've had this issue before where certain hardware down to the chip level would have a backdoor communicating information to a possible criminal. And governments do this. They'll provide chipsets, microcomputers, things that you might not think of that could have a backdoor to them built into the hardware, doing things that you might not know about. And this is really concerning, where you need to look at the cyber physical part of the hardware. What is it communicating to? And do we know all the lines of communication in that hardware system? If you go and buy a printer, does that printer meet information security? Does it only talk to the network that it's connected to, or is it possible that it could be talking to something else that you don't know? And so when you buy these tools to put into your business, who is monitoring those tools to make sure that there's no backdoor going on? And honestly, do we have an underwriter's laboratory looking, or some cyber underwriter's laboratory looking at the hardware part to see that it's only communicating to where it's supposed to go? And when you buy this stuff off the shelf, you really don't know all the time really what it's doing. And so this is why we need to have better control.
Is there a role for, I'm starting to take questions from the chat. Is there a role for insurance providers to require better cybersecurity controls? And this from Tom Edwards.
Cyber insurance providers requiring people that are looking to get the insurance to have certain tools in place, endpoint detection and response technologies, SIMs, IPS, and if they don't have them, they won't insure them, or it's an astronomical rate. They are starting to push for that. I think the last 18 months, they've kind of got caught with their pants down a little bit, and they had a lot of claims against them. They're now starting to require it. And we have customers all the time that are saying, my insurance provider says I need to do this, can you help us? And then we have to come in and help mitigate that risk and show that to the insurance provider what's being provided, so they'll underwrite the policy for the company.
Wow. Yeah. All right. So I want to invite questions from the audience. I believe we have Shailene and we have Art Larson. So let's give them a chance to ask that questions for the panelists.
Hi, this is Xiangming. I actually may not have a question, but a comment, because Udi and I, and perhaps even Tom Edwards, we were focusing on cyber physical infrastructure security. And me coming from testing integrated circuits, that's my technical background. we started in 1960s. Chips need to be tested. Design need to be correct in order for it to be testable and secure. So hardware security is difficult because it's hardware. It costs a lot of money to make changes. It's not like software, you can have patches all the time. So yes, we can talk about insurance to mitigate any people that get hurt and so on. But how do we, in this kind of environment, okay? And you can have design rules people to follow and encourage private sector to make their system secure. But hardware security is not like the software. You can run static analysis, you can run dynamic analysis. So let's be realistic. These people are dealing with hardwares, and it's simply impossible, difficult, costly, and so on. So how do you suggest that? If that's what we're talking about, infrastructure. If we're talking about network security, software security, that's a lot more doable, quicker than hardware. And as I try to give you an analogy of the integrated circuit testing, took 60 years and it's still going on because chips are getting simply more complex. So it's like you're chasing after 60. So I like to get a comment about how to, I know education is one thing, but threats are real. They don't wait and so forth. So I'd like to get some feedback and viewpoints for those of us that are in physical system security area.
The physical side of the house is lacking. It needs certain industry like underwater or United Laboratories or some seal of approval type agency, a neutral, that's what I'm looking for, a neutral agency that evaluates consumer and industrial hardware and evaluates that for breaches that could occur in the system. Because when you buy something off the shelf, you really don't know what it could be doing. And this is how our adversaries figure things out. This is how our criminals figure things out, because there's hardware breaches, and we have to be really concerned about that. So it'd be nice to have a neutral agency put the seal of approval for information hardware assurances. And I don't think in the consumer sector or the commercial industrial sector there really has a setup like that. In the military, yes, the military has functions that evaluate hardware very closely, and a lot of time and effort goes into that because our military assets are part of our national security. However, from this, like I said, from the standpoint of consumer industrial hardware, it needs improvement. You need industrial councils, you need industry to combine and establish a neutral agency. I don't know of any at the moment. There might be something in the works where products go through evaluation before it goes to market. If there is something like that out there, we need to endorse it, and the government needs to endorse it because there's holes in the system, and we see it in the news all the time. Now that's the cyber physical side of it. The network side of it, we have to, that's something that always needs to be monitored. And so we have, the folks here that are at this luncheon here need to understand there's the hardware and there's the software aspect of it. And we need to be protecting both of those. And we need workforce development and education and understanding how these systems have to be evaluated. Over.
Thank you. Thank you. I want to invite Art Larson to ask one question. I mean, you posted a lot of questions, but pick one and let's see if we can tackle that.
All right, with respect to what Sherwood and Ms. Wu said, you do have GenRad automatic test engineering equipment, and you do have penetration testing technologies, and you do have performance analysis technology where you use a system under test, which is basically you run scripts against it to verify how it's operating. Those technologies need to be integrated together and obviously updated to run cyber security criteria against hardware devices. So you need to standardize those technologies into an integrated cyber security analysis solution. Anything being worked on in that area?
Yeah, I mean, in the military side, which I know quite well, we have systems that our contractors develop, and we have to monitor them from the hardware all the way up, and we have various vendors that test this equipment. They look for sneaky things that could be going on in the system, and they have to go through all these assurances before that piece of hardware can make its way into a platform when I say a platform, a military platform, an aircraft or a ship, piece of military hardware. So they're hardened systems that are evaluated to make sure there's no backdoor. And so, but on the industrial and the commercial side of the house, it hasn't gotten to the point where we have agencies, neutral agencies, evaluating those kind of systems, because technology moves quickly. Vendors want to get a product to market quickly, but where are they sourcing those internal parts from? And when they source those internal parts, are they being evaluated closely? Because a business wants to source a part and get it at a low cost so they can make profit on it. But what are we doing to ensure that they're sourcing those parts, those chipsets, those devices that take in data and output data, and those microcontrollers? We don't know necessarily we have enough infrastructure in place to evaluate those systems, and we have to have specifications. We have to have protocols for what these things, how they have to communicate, and we have a lot of that. But are we missing something here? And I question that. Over.
I see something that's missing. If you look at the way cybersecurity is set up, it's based on telephone system technology. Anyone can call anybody, any place, anytime. Okay. With security, you want to say, are you in the right organization? Do you have the right authentication, the right role to access that information? Okay. What that means is, if you go all the way back to the Rainbow series and the Red Book, where they said we need organizational control mechanisms, we do not have that. And that means redesigning the communication systems all the way down to the network address table to include organizational roles, controls, and cipher keys. And you got to build a system up from there. That's a very expensive proposition. Until we start thinking and devising standards in that direction, you're going to have somebody who's able to get into a network and pull everything out of it.
Yeah, and I'm I might be sounding the alarm here, but this is the truth that we face as a society moving forward when we're advancing technology, and we're good at advancing technology, but are we good at assurances to protect our infrastructure as we move these technologies forward? And I seriously doubt we're doing enough about that. And when we start to, and I go back to education, when we start to educate our youth better about some of these gaps that we have and concerns that we have, they can do something about it in the generations that are coming up. I don't know that we have enough understanding across the board to be and funding to be able to solve all our problems, and we're not, but we have to start putting some things into place to better give us the better assurances for the hardware aspect of it, in addition to the network aspect of it. Over.
One aspect of the hardware is the quantum machines are coming on board pretty fast. So these machines are going to be on the low end 1 million times faster to possibly 3 billion times faster than the machines we got now. What that means is they can just literally hack through the cipher keys and break into any system. So what does that mean? A real simple solution is you build cipher keys which are bigger. Okay, so that means basically your cipher keys have to be about 40 times bigger, which means you need a megabyte cipher key versus a 512-bit cipher key. So what does that do? You can do that with the current technologies, current encryptors, but you'll have to run through them like 40 times. So if you have a gigabyte encryptor, as an example, And now you have to encrypt it with 40 different times with 40 different keys to actually make it secure against a quantum machine. You've basically decreased the performance of these communication systems by a factor of 40. Okay, so we can secure it, but there's two big issues there. Who's going to generate all that key material? Okay, and who's going to actually be able to put up with the degrading of your communication networks being 40 times slower?
Yeah, there's definitely trade-offs.
Right.
It's definitely trade-offs there, and it's going to have to be defined on what the requirement is to operate and what kind of environment is it going to be in to help define, you know, what the trade-off is going to be on that.
Okay.
Yeah.
We've worked with them to try to modify our program to identify not only the hardware issues as well as software and network, and combine the entire program to do that. We've modified our endpoint detection and response tool to monitor things real time, leverage artificial intelligence and orchestration to try to identify when changes are taking place based upon what is commonly used and not. And I learned on that. It's been an actual long road. It took us literally, I think, 14 months to deploy. Once we deployed, we actually saw quite a bit of things, which is a little scary, but it's starting to move us in that direction. The goal is as we continue to advance and deploy and look at ways to do these things, we can then possibly bring those to the, you know, private industry or commercial sector outside. But right now, we do have one use case where we are attempting to do exactly what you're discussing. It's not easy, I will admit that.
Steve, this is all in your department. What about research? What's coming up?
Yeah, and this ties a little bit back to some of the government controls as well, because we have, for example, new technology that has a natural market pull in which companies will go after, produce, and get to the consumer. I think where we face challenges, environmental, cyber type solutions, is when the companies, for example, don't have the incentive, say, driven by a government mandate, to get a new technology that can provide a solution to market. So I think we've definitely had technology on the shelf based that could solve problems. But when we try to move it forward, a lack of regulation has kept it on the shelf, even though it could be a potential good solution. So, you know, we've definitely we're innovating in that direction, but it's a complex environment, and that's been our experience with lack of regulation.
So if you need help, I got a small consulting company. I'd like to see if I can work with you guys.
Yep.
Okay.
Chat with me after.
All right.
A lot of buzzwords were said right on in terms of regulations, incentive, and Scott mentioned that his company has something. I really wanted to hear about it. And again, I just have to re-emphasize my background. I came from making chips, all the physical system start, you know, at the baseline, making chips. Security has to start from making chips. So back in the 60s, we made chips and chips were returned because they were bad. They were manufacturing defects. So manufacturer had incentive, right? Because I think Stephen mentioned incentive, monetary incentive to make the chip testable. So they went up the stream to the designer and say, thou shalt do design for test. Because the manufacturing location, Intel, TSMC, they don't want to get return parts. But security is a different thing. Security should do the same thing, go up the stream and have the designers and the educator, of course, teach the student, thou shalt do design for security from day one. Because anything later on it's a patch-up work, and it costs 2x, 3x more. So where is the incentive? Regulation, you can write rules, but if you're making a chip and so are the others and into a system, and like Woody said, the supplies from here and there, and when system breaks or gets hacked, we don't even know who's the culprit. So no incentive to do a good job of being secure. And because bad guys don't necessarily will attack my system, maybe somebody else's, and I can dodge the bullet. So, um,
But
yeah,
Shai,
regulation.
what
you need
about
money.
response planning and what about IRPs, incident response planning, and taking all those scenarios to the tabletops and even further?
But it costs money. I have a joke about me being in test. Test is a 4-letter word. Designers don't want to see you because you found their problem, and test costs money. And CEO don't want to pay for tests if they don't have to. So you can have all these, grace, all these incentive, whatever, or rules, and so, it's just a battle. So if there's any way, government, you work with government, it has to be a government thing. And another thing I want to say, the fact that TSMC succeeded, well, America is a free enterprise, right? You can start your company, make money and so on. But Taiwan being a tiny little island, it knows that government has to put in money for that to succeed. And that's why they pump in money. And now look what happened. We are dependent on TSMC's chips. There's no chips, no cars, no parts. So at some point, government has to give us incentive to teach the student to implement this thing. And then once it becomes second nature, then, we can pull it off. But I personally don't think we can talk it to death. We can regulate it to death. And maybe I'll buy insurance, okay, fine. If it happens, I'll pay for it. But if it doesn't happen, I'm not going to implement it. I think that's what's going to happen.
Thank you, Shailene.
Thank you. Thank you.
I want to circle back to our panelists because we are in our last couple of minutes. So any closing comments, Douglas, Sherwood, and Scott?
I, really just, it's a great discussion that moved toward, again, chip security and different ways of testing chips. But I guess moving back up to that higher level of that critical infrastructure threat, everything that you guys are discussing and describing absolutely live as ongoing threats to all of our critical infrastructure. And it's easy to lose sight of that physical footprint in the real world and the physical threat that it actually entails, but it moves far beyond the technical to immediate threat, because again, any of these infrastructures, the reason they're so designated, any of them are disrupted because of these security threats, then boy, we feel it, and oftentimes potentially in many ways a lot worse than we even like to envision. So I guess that kind of is my idea of having it come around full circle.
Yeah, number one is we need to have best practices out there. And it can be difficult to implement. It's difficult to get people to understand what do we mean by best practices. But the professionals out there will tell you things about what do you do when you get an email sent to you that's from an outside source and you're not really sure who it's from. Do you open it, take a chance that it can put malware on your computer? It's like tossing a coin up. Is it heads or tails? Is it going to cause a problem or is it not? Do you open it or don't you open it? So you put people in a bind when they're trying to do their everyday job, and these emails are blasted at us. Yeah, we have ways to put certain pieces of mail into junk mail folders, we have certain spam folders, things like that. But it only takes one incident to occur that you might not be aware of, and it can happen to any of us, that opens up the door for a cybersecurity breach to your system. And our industry partners, the folks that evaluate incoming email, we have to keep doing what we're doing and get smarter at it. We have to understand what the best practices are. For example, you shouldn't really take a thumb drive and hook it up to a computer that's on a network because you don't know really what's on that thumb drive. And so when you have best practices, maybe you tell your workforce, do not insert a thumb drive into a computer if we don't know what's on that thumb drive. Is this thumb drive certified? Do we know really what's on it? Because it only takes one incident of a bad file that you can put on a computer to really do severe damage.
That's
so-
spoken like a guy who's been using the military networks for a little over a couple decades, I'm guessing.
Yeah, and the military does set the stage, and we do like to see those kind of best practices infiltrate down to everyday users, because it does help. We do learn a lot in the military, what attacks we've experienced, and they're no different than what could be experienced by everyday people and everyday companies. So I would say the big takeaway from this luncheon is best practices and monitoring your own activity and what you do, and think about what others are doing to try to protect the system and the network, because they'll have advice on how to handle what you have to do. And so I think that's a huge takeaway right there.
Great. Thank you. Scott, very quick, we're running out of time.
Yeah, I was just gonna say, it's a great topic. It's, for us, we keep chasing this imaginary line of how do you go from reactive to proactive? And the line keeps moving. Every time you start to catch up, it keeps going further and further. And for, that's really the goal, is how do you get from a reactive type of security monitoring and support and services and solutions and programs to being more proactive, and getting to that point. And quite frankly, almost everything that's deployed out there today that works is reactive. It waits until something happens.
Excellent, excellent. So with that, I want to thank everyone. It's 1 o'clock, so we have run out of time. Thank you again, Stephen Nappy. We are done another chapter.
Thank
if
you.
have
Great
any-
discussion.
Yes, yes. Until next time, thanks everyone. We'll post a replay.
Thanks, everyone.
Bye-bye.
Take care.
Take care.